kind of do like a work day. And then when we get back from break, we will have a review day, and then we'll have a quiz, okay, over chapter, just over these three sections. 9-1, 9-2 we did on Thursday, Friday, and then 9-4 for today. And then I think that'll be our last quiz of this semester as well. Then that first week back, then probably like on that Wednesday, we will start, we'll spend about a week reviewing for the AccuPlacer. I have like a document that has like all your guys' scores in it for like ACT, GPA, and if you took the AccuPlacer back in the spring, so you kind of know where you're at qualifying wise, and we'll kind of go through those scores with you and know what you need to do to qualify. For college algebra is probably the big one, or we also have, we got a new class, contemporary math, that we can kind of talk about as well. So we'll kind of go through those options with you based on your scores and qualifying parts. All right. Today, we've been talking about quadratics a lot throughout this chapter. Talked about how to solve them using the square root method, using factoring, or even using the quadratic formula. Today we're going to look at factoring or graphing quadratics, and we can still factor and solve and do all of that. But today is going to really be focused more on what does the graph look like. And we've done quadratics before, but if I were to graph a quadratic equation of something that looks like this, and I'll just give you the generic form here. Has all three parts in it. What kind of graph will this always make, no matter what? What's the graph going to look like? All quadratic equations make the same type of graph. Parabola. Good. Okay. It's always a parabola. Okay. And the one thing that will make it a parabola is this value right here. It doesn't have to have all three values, but it has to have the x squared. Okay. This is the one that's essential to make it be a parabola. Your parabola could either open up or your parabola could open down. So it's definitely a graph that we've seen before. Okay, it's pretty common. We even do parabolas all the way back to Algebra 1. Today we're going to talk about how do we know what the graph looks like. Well, we know it's a parabola, but your parabolas are going to open up, they're going to open down, they're going to be wider, they're going to be skinnier, they're going to move left, right, up, and down. They're going to have all kinds of changes that are going to take place to them. How do we determine what it's going to look like before we ever put it in the calculator? It's not wrong to put it in the calculator, and definitely going to let you use your calculator for this, but the equation is going to tell us a lot of information. Okay, so that's kind of just a real basic intro into what a quadratic graph looks like. All your graphs today are going to be parabolas. Okay, they're all going to make that U-shaped graph. There's really two different forms that we're going to talk about. The one I just put up there is standard form, and we'll see that a lot. But we also have what we call vertex form. And in some cases, this is a little bit easier to determine some of the things that we need. The first couple of problems on your assignment today, they're going to ask you, what is the vertex? What is the axis of symmetry? And eventually, they're going to just use the word axis a lot. A lot of times, I'll write A of S up here. So however you want to do it, just know when they talk about the axis or the axis of symmetry, I'll say A of S, just so we don't have to write out axis of symmetry every time. They all are representing the same thing. Okay, so whenever I have a vertex, or a parabola, I have a vertex, I have an axis of symmetry. So in this graph right here, this is what we call vertex form. This number here, the 5, is called our A value. This is called our H value, and this is called our K value. Okay? And it's just the generic letters that they use to represent vertex form. If we wanted to write out vertex form in its generic form would look like that. Okay. F of x represents y, then you have your x, and then the three numbers that are going to change things are your A, your H, and your K. Your vertex is always going to be the H and K value. Okay. It's going to use H and K. But we got to think about what direction we're going to move this. Okay? Whenever you have a number attached to the x, it's going to move your graph left or right. And this is the part that's a little bit tricky. Typically, when we think -2, we would think left 2, if it's going left or right. But whenever it's attached to the x, it's going to move opposite of what you would think. So x minus 2 really means right 2. And then the -3 tells me how much it's going to move up or down. And then the -3 at the end is going to be the same as what the number is. So it's just going to be down 3 or -3. So a lot of times what we'll say is that this graph is moved right 2 and down 3 from the original. And I'll show you what I mean by that here in just a second. The axis of symmetry is the line that goes right down the middle of the graph. Okay? The axis of symmetry is always going to go through the x value of the vertex. So if my x value is 2, my axis of symmetry here would be x equals 2. Okay, so if I drew a sketch of this graph, I'm going to start with my axis of symmetry. It's a vertical line at x equals 2. What that is it's a vertical line that splits the graph in half. It splits the parabola to be symmetrical, right? Symmetrical means it's the same on both sides. So that's the line that's going right down the middle of the parabola. That's why we call it the axis of symmetry. Your vertex is going to land right on that axis of symmetry somewhere, okay? We said the vertex is at 2, -3. So we went right 2, we went down 3, and it's right there on that line. Okay? And we could come up with a few other points if we needed to. I'm going to tell you that you could come up with those points from your calculator. You can, to generate them, I mean, you could plug in like 0 for x and find out what y is, okay? And that wouldn't be that big a deal here. 0 minus 2 would be -2, -2 squared would be 4. 5 times 4 is 20, 20 minus 3 is 17. Well, that's going to be way up there, right? So that probably wouldn't be an ideal point to graph. But as I put this into my calculator, and if you guys have a calculator with you, go ahead and get it out. And let's practice just putting this into our calculator. Right here, this 5 is going to make this graph skinnier. And that's not something we're necessarily going to talk about right this second, but just know that's why it looks a little bit different. If you have a number out in front of the parentheses, then that's going to make the graph a little bit skinnier or sometimes wider. If the number is like a fraction, like a half, a fourth, a third, something like that, then it's going to make your graph a little bit wider than the original graph. Okay, but we call this the vertex form because we can look at the equation and we can immediately tell what the vertex form is. Okay. So if I give you an equation like this, and I ask you for the vertex and for the axis of symmetry, okay? The vertex would be what? -1, and 6. It's going to go left 1. It's going to go up 6. Okay, and we should be able to tell that without ever looking at the graph. It's not wrong to look at the graph to get that, but that's why vertex form is there, is we can easily tell what the vertex is without ever punching it into the calculator. The axis of symmetry is always x equals -1. Don't just say -1. -1 is just a number. What's that mean? X equals -1 is a vertical line. So we want x equals in front because it's a vertical line. So that's a really big part of the axis of symmetry. It's always got to be x equals. Okay, and you could put this into the calculator. We'll do some more stuff in the calculator here in just a little bit. Because this 2 is negative, there's two things that are going to happen here. Number one, it's going to be skinnier, okay? But the negative is going to flip it upside down. So if you wanted to put this one into your calculator, then it's going to look something along the lines of this. Left 1, up 6. Here's my axis of symmetry. And then it's going to open down. And that would be our graph. One of the key points that I usually try to find is the y-intercept or even the x-intercepts, and we'll talk more about that here in just a second. But that's where we can pull on some things that we did last week. Okay, so that is what we call vertex form. Okay, if we do standard form, this is the form that we're used to seeing, that we saw last week when we did a lot of factoring and things like that. Okay, so in this one here, we have the A, B, and C values. We don't necessarily deal with the H and the K and all that we just talked about. So this one's a little bit more familiar to us. The bad part about standard form is we can't just look at this and say, there's my vertex. And so I can't necessarily determine what my vertex is right away. Now, you can use your calculator for this. You could graph it, and sometimes getting the vertex off the calculator, you got to be able to zoom in and see where that minimum or maximum point is going to be. Calculator's not a bad option here, but I'm going to show you how you can do this by hand also. When it's in standard form, what we're going to do is we're going to flip-flop it. We're going to find the axis of symmetry first, and then we're going to find the vertex. If we didn't use our calculator. So there's a little formula that you can use to find the axis of symmetry. That is -b over 2a. It gives you the axis of symmetry out of standard form every time. Okay, my b value is 16. So the opposite of 16 over 2 times 2. Which is 4, and that would be -4. So my axis of symmetry would be at x equals -4. So if it's asking me to find the axis of symmetry, that's how you could do it by hand. X equals -4. Okay, my vertex, we're going to use this. If I say that x is -4, what we talked about just a second ago is the x value of the vertex is the same as the axis of symmetry. So this number is going to be -4. The x value of the vertex will be -4. How do you suppose we could find the y value of that vertex? If I have an x value, how could I find the y value? Plug it in. Yeah, we have an equation, right? So let's just plug it in. We're going to put -4 in for x. Really be careful of your signs, and that's why I'm using parentheses here, because when I square -4, that becomes 16, a positive 16. So this is really 32 minus 64 plus 27. And you don't necessarily have to simplify like that. You can just put that into your calculator, but if you do put it in the calculator like that, make sure you use parentheses so it does the order of operations to it and puts it all in the right way. So when you put that into your calculator, you should get -4, -5. And that would be our vertex. Okay, so if it's just asking you to find the vertex and the axis of symmetry, that's how you could do it by hand. Like I said, if you want to put it in the calculator and find the vertex and axis of symmetry that way, I don't have a problem with that. But just know the calculator is not going to tell you what the axis of symmetry is. So the axis of symmetry is always x equals whatever the x value is of the vertex. Okay, and that's how you could find it if you did put it into the calculator and didn't use that little formula that we just talked about. But this would be the way that you could find the axis of symmetry anytime you have standard form. Okay, if I gave you one like this, f of x equals 4x squared, and I ask you what the vertex and the axis of symmetry is going to be. Okay, so this one, remember I told you to make it quadratic, we have to have an x squared in the equation, right? Well, we do have an x squared, but this is missing its other two parts. It doesn't have the b and c values. So we could put this into the formula and we could do all of that. But if all you have is the x squared part and there's no b and c value, where's the vertex always going to be? 0, 0. So my vertex is 0, 0. If it's missing the b and c value, vertex will always be 0, 0. Your axis of symmetry is x equals 0. X equals 0 is really the same as the y-axis. Okay, so the y-axis is the line that's going to be splitting that parabola right down the middle. So if we graph it, and so the reason I show you this one is because do we really need to put this into our calculator? Hopefully not. We should be able to know that one immediately if I see the b and c values missing. Okay, the last thing that we're going to talk about here is graphing and what are some things that I'm going to be looking for when we graph. Okay, obviously the vertex and the axis of symmetry are going to be two huge parts of our graph. But there's some other things that I'm going to kind of show you that when we graph it, we want to be fairly specific about when we graph, which means we want to use some points. We don't just want to take a parabola and say, boom, goes through 0, 0, so there's my parabola, right? We want to get some points that are fairly specific to what we're doing so that our graph's a little bit more accurate. I'm going to give you some examples here. H of x equals -3x squared. We're going to do a couple of them that are just x squared, and then we'll keep adding a little bit more to it as we go. Okay, so immediately, my a value here is -3. That tells me two things. It tells me that this graph is going to open down. And it's going to stretch by a factor of 3. Sometimes I might use the word skinnier because in our mind visually that makes a little bit more sense. Okay, the book's not going to use the word skinnier or wider, but I like to use the word skinnier and wider because I think visually it helps us to understand it a little bit better. But it's going to stretch the graph. So if I stretch something, it's going to make it skinnier, right? It's going to thin it out. The other word that sometimes is used is compression, where I'm going to compress down, and that's going to make the U get a little bit wider. But skinnier versus wider. My vertex here is 0, 0, because there's no B and C values. My axis of symmetry is x equals 0. So if we were going to sketch a graph of this, here's the things that I would be looking for, okay? It's going to start at 0, 0. That's where my vertex is. I always put the vertex in the middle of my table of values. We want a few points in the table of values. And what I would really want is I want at least 1 point on either side. So we're going to want at least 3 points, 1 point to the left of the vertex, 1 point to the right of the vertex. And I don't necessarily care how far away you get. So like here, I'm going to go a point to the right and a point to the left, so I'm going to go -1 and +1. You can do this in your calculator, okay? I don't have a problem with that one bit. You can go to your calculator, you can type in -3x², you can go to your table, and you can generate the points that way. But I want you to generate some points one way or another, okay? Just so we know kind of where this is going to be. And so if I were to plug in -1 here, or a +1, the reason we call it the axis of symmetry is because this point is symmetrical. So when I take a point here, I can just flip it over this line of symmetry right here, and it's symmetrical. And that would be the same for any point that falls on that parabola. It's just reflected or symmetrical about that line of symmetry. So there would be 3 quick and easy points we could generate based on those points. Okay. And a lot of these I'm not necessarily pulling them up on your calculator. You could pull them up on your calculator if you want to, but I'm probably not, just for the sake of saving a little bit of time. Okay, I am going to pull this one up. Here, my A value is 1/4. So that tells me 2 things. It opens up because it's a positive number. And because it's a fraction, then this is going to be a little bit wider. We haven't talked about or seen one like this yet. It's going to be a little bit wider than my original graph. My vertex is going to be where? 0, 0. It's not going to move left or right. Anything that is just x² is always 0, 0, which means my axis of symmetry is x equals 0, or if you wanted to say the y-axis, I'm fine with that. That might make more sense to you, just to say the y-axis is my axis of symmetry. The only time you can do that if it sits right there on the y-axis. Okay, if we were going to graph this one, I kind of picked this one. 0, 0 is my vertex. It's going to open up, okay? Now, you could use 1, but one's usually a good go-to number, but when I have fractions, it may not be my best go-to number here, okay? So probably what I want to do is I want to use something that's a little bit easier. I want to use nice whole numbers, right? I want to try to stay away from fractions if at all possible. And in this case, if I were to plug in 2, for instance, 2 squared is 4. 4 times 1/4 gives me what? 1, okay? So 2 would probably be a little bit better number to use. If I plugged in 1, I would get decimals. That's going to be a little bit harder to graph. So that's why I would probably choose 2 here. And if I plug in -2, I'm also going to get 1. Okay. I told you I was going to pull this one up on your calculator. Okay. Here's one I haven't seen yet. This one has an A value and it has a C value, but it doesn't have a B value. We saw some of these last week when we solved, and we used the square root method to solve. We're not necessarily solving today. Today we're focused on the graphing portion of this. So if I ask you where the vertex of this graph would be, and I know we can put it in the calculator, but where do you think it would be before we put it into the calculator? What do you think is going to happen here? What's the -3 going to do to my graph? It's going to go down 3, okay? And it's not going to move left or right at all, so my vertex is 0, -3. So anytime it's missing a B value, the vertex is going to be based off of what this number is here. If this was a +3, it would go up 3. If it's -3, it goes down 3. My axis of symmetry is, once again, x equals 0, or the y-axis. So I'm going to go down 3. Okay, the 2 out in front is going to make it a little bit skinnier. In this case, 1 probably would be okay to use. You could do other numbers as well. But if I plug in 1, 1 squared is 1, 2 times 1 is 2, 2 minus 3 would be -1. And those should be the same thing because they're symmetrical to that point. And there would be my graph. Another thing that I want to tie in here is one like this. We've got 2 more to do here. And I want to show you this just so you can kind of see where some of the stuff that we do last week will tie into what we're doing right now. Okay, if I graph this one, then I know that it's a standard form equation, so I can find my vertex either by hand or by the calculator, and doing it by the calculator is totally fine, okay? But if I were to find this on my calculator, let's find out where my vertex. And that is one I definitely would use my calculator for, rather than trying to do it by hand, okay? We could do it by hand, but using our calculator there would be a little bit easier. Okay, here's where I want to tie this back to what we did last week. Last week we talked about factoring this to solve it, right? We want to know what the solutions of this are going to be. Well, this is a trinomial. Once again, if I was going to factor it, there's no GCF, but I would try to do product and sum. So what multiplies to get 4 and adds to get -5? -4, -1. So this would factor into x minus 4, x minus 1. And then what we did was we solved it, right? And we said if I set both of those equal to 0, I would get x equals 4 and x equals 1. And what that is going to tell me, just so you know that this is part of your graph, those are 2 places where it's going to cross the x-axis. So my solutions from last week will also be the places where this crosses the x-axis, okay? And that's where this is going to tie into what we did last week. And then I'm going to put my vertex down here. You're just going to kind of have to estimate about where it would be, but it should be split in the middle between those 2 points. And there's my graph. Okay. So what I'm showing you there is those would be 2 quick and easy points that I could come up with that would be part of my graph. 4, 0, and 1, 0, as well as the vertex that we talked about. Okay, remember that not all parabolas will touch the x-axis, and sometimes they don't have to cross. If I gave you an equation like this. Let's first of all think about what the factoring would look like here. There is no GCF, so if I factored this out, what would be the two factors of this polynomial? What multiplies to get 9 and adds to get 6? 3 and 3, right? So we're going to go x plus 3, x plus 3. Well, because they're the same thing, then my 0, or my solution here, would be x equals negative 3. Okay, and here's what we're going to find out. Not only is that my solution, and there's only one solution because they had the same factor, right? But that point is also my vertex. That's where it's going to come down and hit and either go back up or go back down. Okay, so I need a couple of points other than that. So maybe we plug in negative 4 and maybe we plug in negative 2. You can plug it into this equation or you can even plug it in here. If I plug in negative 2 here, negative 2 plus 3 is 1. Negative 2 plus 3 is 1. 1 times 1 is 1. Okay? So pretty easy to come up with a point. And once again, if you needed to, you could use your calculator, but know where those numbers come from is a really big thing. And then we can graph those points and we can get our parabola. Okay. But everything is a parabola. So when graphing them today, I want you to come up with at least 3 points when you do the graphing portion of it. You don't have to graph every single problem today, but when you do graph it, 3 points is kind of what we're looking for. What would be the domain of any parabola? All real numbers, okay? My range is going to be all y values greater than or equal to where it hits the y-axis at. So here it would be y greater than or equal to 0. All y values greater than or equal to 0. If it goes down, it would be less than or equal to. Morning, Deja. Okay, so a couple other things that we didn't mention, but those are things that we have. All right. Assignment today. Let me look here for you, Chloe. Make sure I included all your page numbers for you. Today I did. 561, 562. Okay, pay attention to the directions. Like for instance, on the last couple, it asks us to find the x and y intercepts. State whether the parabola opens up or down. Find the vertex. Find the axis of symmetry. Graph it using some points. One thing that we did not talk about here is domain and range. There are a few questions talking about domain and range.